Hello team, my name is Mahesh. In this video, we are deploying a Zomato application on the Elastic Kubernetes service, which is provided by the AWS itself. It is a fully managed service, and it will provide an enterprise grade Kubernetes engine to deploy a pod and deploy our application on the AWS EKS itself. It has several advantages that are also provided by the open source solutions. But as an enterprise, we are deploying our application on the EKS today. So our EK on the last part, you will see a video over here. This is the part one. I'll highly recommend you to watch this part first. On this part, we have deployed that image to the Docker itself to test that application locally, if it is working fine or not. And throughout the today, we are get pull that image from the Docker itself. We are deploying that image to the EKS itself through inside the pod itself, and throughout the ingress controllers, the IAM service accounts, the permissions, policies that we are totally looking on this video. And throughout the load balancer, the IAM service account will create a service load balancer automatically for us. And throughout that load balancer, we can access our application itself. Firstly, for deploying that app, firstly we need to provision our EKS cluster. We need to provision our resources on the AWS itself. We need to create an IAM rules. What we need to create an IAM rule for? We need to create an IAM rule for the cluster, which is our EKS cluster that we are looking that we used. And inside that cluster we have a pods, and that pods are attached with the IAM service account policy. And throughout that, it can integrate several other services also. So several other AWS services. So now what we need to do, I have configured my AWS on this machine itself, on this particular server itself. Sorry, AWS configure. So firstly, you on this, I have configured my AWS credentials, and throughout that, it is connected with my AWS account. Here you go. I have an account over here. So instead of creating and clicking thousands of buttons, what we are doing, I have created the commands throughout the AWS reference CLI reference tab. You can get these commands, and throughout these commands, you can implement uh, this same project. So what we need to do today, I have created the bash examples repository on my account itself. Once you go on this account, go on repositories. Inside the repositories, there will be option for bash examples. Inside that, you have option for the AWS EKS commands. Inside this, in the commands.md, you will get this reference. So I'm just looking in the code section. So before that, we need to clone this repository. So what we need to do, get clone, and we have placed this repository address. So once it will clone, we can run the commands. So on the commands itself, because we have a JSON policies documents. Inside these JSON policies, we have particular permission that we are assigning to that role. So we are creating a EKS cluster policy, and it will provide the policy document as EKS cluster.json. Inside the JSON file, the all the permissions that are required by the EKS cluster are mentioned over here, such as it is allowing the EKS to access the other. It will allow that particular role to access the EKS service with that. So throughout that, we will we will create an role. So let's go on bash examples. Yes, commands. Inside that commands, what we need to run that command. Once it's done, it will create an IAM role for us. Look, it has created a EKS cluster role. So cluster role is created. Now we need to create a node group role. Node. Why we need that? Because we need a EC2 machines to host our application, to host our pods inside that. So with that, with the node group, we will provide the permission to the EKS cluster to automatically deploy the pods into the AWS EC2 inside the EC2 itself. So inside the EKS node group, here, there you go. Here is a JSON file, and inside that it has permission to allow do the actions on the EC2 itself. So we are allowing this. We are creating this policy. Once this policy is created, yeah, it has created the policy node group. So I'm clearing the screen. Now what we need to do, we need to attach the policy to the EKS cluster policy and the node group. So we have created the role. We need to attach some policies or permissions, we can say, and throughout this we can allow um, we can allow the permissions. So policy ARN, it is Amazon resource name, which is already defined by the AWS itself. So I have just copied the ARN and the role name, which it will connect, which is this role, cluster role. So once I done that, it will attach to the cluster role, and this is worker node policy. What it will do, it is ECS worker node policy. It has these policies are already created by the AWS. Just we need to allow to our roles itself. So one by one, we can. This is Amazon EC2 container registry read only. So it will allow. It will also attach to the node group role or our node group role. So once it done, we need to attach the CNI to the node group, which is another policy. So once we attach those policies, we can look over here and the graphical control, we can see EKS cluster role. Inside a cluster role, we have one policy which will allow us to do actions on the EKS cluster itself. It has all the resources, all the permissions to access the cluster itself, access the resources itself inside the cluster. And the node group, we have allowed for three policies, which is the container registry read only, CNI policy, and the worker node one. So we have allowed three permissions over here. And now what we need to do, we need to go and create one ECS cluster. So again, we are using the command because in the command itself, it is quite easy to create a EKS cluster. But when you are doing that manually, you need to configure a lot of options. So let me give an overview about it. So inside this cluster, you need to once you do the create, you need to configure the cluster, the version. You need to configure the IAM role for a specific cluster itself. There are a lot of things you need to done in manually. You need to specify the networking, you need to specify the observability, you need to configure the add-ons such as API servers, the scheduler, the kube proxy, kube config, all those things. So you need to configure additional settings, and you can, after that it will create a cluster. So before by doing that, otherwise by doing those things manually, what we can do, we can just go on the code section and we can just use this template, as in use this template to create our EKS cluster. So I'm copying this command and let me give an overview about it. So we are creating a new cluster. Name will be the Zomato demo cluster. It will present on the region. It will create on the AP South one, which is my current region, and it has a role, which is our cluster policy that we have created a few just moments before, and the resources, which subnets it will require. In the which subnet it will attach these policies. You can change according to you. I have created a security group. I'm using one security group that has all the permissions. So with that security group, it has connected. It will connect, and the Kubernetes version is 1.28. So it's older one. So let's go on at 29. Once I click enter, it will require some time, and it will give us a EKS cluster. So once we have run this command, just go over on the status tab. You will see that it is in the creation stage. So according to your network, it will require some time to set up an EKS cluster. It is currently in the creating mode. So throughout this, we can get the overall idea about the EKS cluster. Inside the resources tab, we will get the information about our pods, the replica sets, the daemons, the cron jobs. The we are if we some provided some scheduling activities, or inside the clusters we have a nodes, we have a namespaces. We can look how we can create our custom namespace to deploy our Zomato clone application, the API services. What are the API services you will see once the EKS cluster is created. Inside the services tab, we have an ingress controller, we have a kube DNS or the kube API, the API service. So all those things are present over here inside this. So this is by default provided by the EKS itself. But when you are doing practicals on when you are installing a EKS cluster on your local, such as the Minikube or K3s or K8s, you need to additionally add those. You need to additionally add, we can say, dashboard for this to manage the entire thing on the graphical page. So, such as the Rancher Labs have provided the graphical basically dashboard. For that, you need to install that particular dashboard to support on the K3s model, K3s itself. So, that we need to do on the manually, but it is already provided in the EKS by default. So it has creating a networking, it has creating a routes and attaching the security group to the particular EKS cluster itself. Inside the we don't need this. Inside the resources tab, we have a multiple options that are also provided by the open source solution also. But for the EKS cluster, it is an enterprise solution. With that enterprise solution, you can access, you can get those resources to access it, and it is quite simple to use it. So, but it requires some time. Let's allow, it will take around 10 minutes, hardly 10 minutes, depend on your network itself. Once it's done, you will see, you will see it is in ready stage. So, while it is creating a cluster, in the meantime, what we can do, we can set up our pipe. We can, what we can do, we can set up our pipeline, which is automatically run. We are like with the GitHub Actions itself, we can edit this deployment pipeline, and we can add additional stages to we can say additional deployment stage to deploy our deployment.yaml, which is throughout the deployment.yaml, uh, we can we can say we can deploy our application, we can deploy our services, and throughout the deployment.yaml, we can integrate, we can run the command from the GitHub Actions to directly to the Kubernetes cluster itself. So what we can do, open VS Code, and in that VS Code, we can create a new file. In that file, let's create one file, deployment. There you go. I have already one file. It's deployment.yaml. Yeah, there you go. So inside that deployment dot inside we need to add another workflow over here basically. So what I can do, I can provide the name of the workflow, which is configure AWS credentials, because it need to be authenticated with the AWS itself before we running a Kubernetes or kubectl command. So what we need to do, we need to do uses uses it uses AWS actions / AWS configure credentials at the rate v1. So it is version 1. So now with we need to provide the environment, which is the AWS access key ID, dollar, in double brackets we need to provide the secrets. Inside the secrets, we can secrets AWS access key ID. Same with the AWS um, AWS, we can say secret key, secret ID, not the secret AWS access ID. We can say AWS secret access key. So on the dollar, we can uh, we can provide the another secret. Inside that secret, we have a secret access ID. Um, secret 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 access ID. Okay, might okay, secret access ID, secret access key ID, and the secret access key. Okay, perfect. So, and now we need to provide the region. Those three things are mandatory to run those things. What we can do, we need to provide another secret, which is secrets dot aws dot region. So where I have set these commands on the when you go on the particular settings tab of that repository, when you are fork this repository on the settings tab, you have an option to secrets and the actions. When you click on secrets and actions, you will get the option over here. Click on add new repository secrets. You can provide the variable names as you provided over here, such as this one. And once you paste this thing over here, you can provide the access ID. You can create an access ID with that uh, in the IAM section itself, and throughout the access ID, you can paste access ID and secret access ID over here, and you can call securely on your we can say on your pipeline itself. So let's now first stage is done. We need to update our kube config. So another stage, we can say update kube config, and inside that we need to run our shell command aws EKS hyphen hyphen no aws EKS update kube config hyphen hyphen name, our application name, what we have provided our application name. Inside this is Zomato cluster app. Look, it is on the active stage. So this is our application name, and we need to provide the region. So inside the region, we have a AP South one. So I have a, with that we can get the kube config on our local. Now what we need to do, we need to deploy that particular deployments.yaml on the Kubernetes cluster itself. So deploy to Kubernetes. Inside that, we need to run another command, which will run directly on our GitHub Actions runner. So this is the command run um, kubectl apply apply sorry apply hyphen f deployment deployment service.yaml, because I have a file over here deployment service.yaml, because of which it has get that particular YAML file itself. So our we have created this thing. Now we need to just commit on your our repository itself. So over here, click on edit, and you can just paste it over here. Once I commit this, it will automatically run this GitHub Actions file, and it will get some errors because we haven't provided the deployment.yaml file on our GitHub Actions itself. So if it has connected to the Kubernetes itself, it will not able to it will not able to deploy our application. So what we can do, we can go on again our on the over here inside this deployment service.yaml. I'll show you to how you can write in from the basics itself. So okay, so first we have a API version. We can call this is the API version. What is the kind of deployment? It is a deployment. Metadata is basically the information about the particular we can say particular stage, which is it is a Zomato application specifications. It has one replica and selectors. Uh, Throughout the selectors and labels, we can reference to the another service itself. So let me show it to you. Throughout the reference, I have provided the um, this particular service itself. It is a service stage. Inside the service stage, it is creating a load balancer, and it will throughout the selector and the labels. It is directly attached to my deployments to the to my deployments directly. So this is how the things work. And in the templates itself, we are using one template, which is Zomato. Um, Throughout the selectors and the templates, we can integrate various services. And in the specifications, we have a container a name as a Zomato, and we can provide our we can say our image, a particular image which is running on port 3000. So same as before, we have API version. What kind of a resource it is? It is a service. The metadata, the particularly we can say name of that particular service, which is the Zomato service. The selector, it is connected to the my pod itself directly. And it has we are exposing the port. The first port is our we are accessing that website on port 80, and the target port is 3000, which is our container port. So this is our deployments.yaml. And yeah, so now let's check the status about this. So what is the issue? It is get only deployments. A job has failed because why? Um, okay, let's retry all the jobs. Uh, we have we have created our EKS cluster itself. Look, we have overall things such as we have a OpenID connection. We are implementing this OpenID connection broker on our to authenticate with the our application itself. So what it can do, it has authentication broker which will which will connect on, such as there will be option for the like on some website you can see there will be one option. It is provide the authentication mechanism to access the specific pod itself. Basically, on specific application, we will see sign in with Google, sign in with Facebook, all the sign in with XYZ. So throughout this connection broker itself, you can all configure all those things. So we are configuring this thing itself. So not for now, we what we need to do, we need to create a node group. Throughout the node group, we can specify the configuration that will require by the pod itself. So we are providing the name, we are providing the IAM role for the node itself, which is our EC2 instances that will create in by default in the background itself for the auto scaling and the configuration. Basically, what type of machine it is, what are the configuration of it. So all those things are we'll get on this. So let's describe the cluster that we have created. Zomato demo cluster. It has in the active stage. You can see it is as certificate authority active. So let's now go and create a node group itself. Inside this node group, I can explain the overall things. So it is a node. It is a AKS node group, and the cluster name, which is which cluster it will connect. The node group name, we can provide any node group. We need to attach a node role, which we have created just moment before. Inside the subnets, you can specify the subnets, and you will get it from the VPC section. The scaling configuration. So it has automatically scale your containers according to According to the load, it will get basically the concurrent users are accessing that web page. It will automatically scale up and scale down. The design size is 1 and my max size is 3. So it is region AP South 1 instance type T2 dot micro because we are kept in the feed drive, and it is a Amazon Linux tool. So it is 84 by 64 architecture, and once we click enter, it is quite simple to do things on the CLI part itself, because it is quite when it, throughout the GUI itself, it will require much more time to create resources. So it has creating a desired state. So if you can see on the over here, uh, let's go on AWS. It has creating a EC2 images. So look, we have already one GitHub Actions runner, and it is creating another one. We'll see in some time. It is on the pending stage. Um, it is in creation stage. Let's go and try now. Click on refresh. It is still in creating stage. Okay, no worries. It is creating right now. Look, it is on the pending stage. It is created 22.micro for us. It is still on pending stage, but so okay, it has started, and we'll get an error. NPM is not found. Okay, we need to install that. API can get updated, and API can get installed npm star, and API can get installed docker io, and then it will install all those things which will require to run overall pipeline. So okay, it has completed the installation. Let's verify it is done or not. Docker ps and then npm. Yeah, it is working. So let's rerun all the jobs. We will see overall logs. It has done. So now what we need to do again, we need to create. Currently it is checking the vulnerabilities in the dependencies itself. So it has found the 19 vulnerabilities. It has completed the sonar cube analysis. It has completed the post checkout code, and now it is deploying. It is doing a pull. So it is pulling that image from the Docker itself. It has getting permission issue. So what we can do, chmod 777 on that particular var, the sock file, that service file, we can provide the permission to run by every user. So we are providing the full permission to that Docker sock, and we also provide the users to permission, or we also provide the user to access the Docker service. So how we can do that? User mod icon a capital G, our username. Sorry, our uh, we can say our group name and the username. Ubuntu UBUNTU, and our root user root. So once you click the Ubuntu um, ID UBUNTU, okay, ID UBUNTU, you will see it has permission of the Docker. So let's rerun this particular stage again. It is picking the job. Um, and yeah, it is pulling that image from the Docker itself. On the last part, we have built and we have built the image. We have done the tree scan, and we have pushed that image from to the Docker itself. Now what it can do, it is pulling that image from the Docker itself, and it will uh, configure the AWS credential, and it will push that image to the Docker Kubernetes itself with that deployment.yaml that we have created. Uh, that we have uh, we have created the deployment.yaml file. So what we need to do in the meantime, we need to create an ingress controller With that ingress controller, we can provide the IAM service. We can create a service account for the AWS load balancer, and the AWS load balancer and the EKS will get connected. And throughout this ingress controller, uh, throughout this IAM policy, we can connect our load balancer and the EKS itself. So inside this AWS control policy, you can see it has permission. The this policy have permission to access the elastic load balancing, the EC2, and all those things. So it will create, and it will attach the policy directly to that. It will create and attach the policy. So now let's create an ingress service role. Throughout this service role, the pod get access to exposed to the internet and serve the application. Basically, you can expose the particular pod with that ingress controller to serve that application inside the pod. So what we can do, we can clear out the screen, we can run another command, and it will I create a policy for us, because I have copied, I have cloned this repository. So I, I I can create the policy directly. So the policy AWS controller IAM policy is already created. Okay. So duplication is not allowed. So what we can do now, it is created at my end. It will create by default on your environment directly. Now we can do what we can do. We can create a IAM role. We have created the policy. We need to attach that role to that particular role. We can create a role, and inside that role we can attach the policy. So the inside this role we are attaching the IAM trust policy. So inside the trust policy, it will allow the traffic, which is it will provide the API. It will provide all the API calls to the EKS to the EC2, EKS and the EC2 itself. So it will create an IAM role. Uh, Throughout this IAM role, it has already existed at my end, because at last time I have created when I do doing practical. So it is created, and we need to attach the policy. We are creating the ARN Amazon resource name, which will use by our load balancer itself. So load balancer have access to the ECS and the EC2, sorry, EKS and EC2, and it has also permission to create a load balance. It has also permission of the load balancer. It has also permission to the EC2. So this particular service account, which is used by this particular role itself. So in that particular IAM service account, we need to use this role. So why this account why we are creating this account? So basically, if someone look one example, if some developer wants to integrate other AWS services, so what a developer can tell you, you can create one service account, and throughout that service account, you can integrate various services to your pod itself. You can connect the integrate various services with your pod. So because of which you need this service roles. So we have created the ARN, we have attached the policy to specific role, and created a policy ARN. So what it's showing, policy ARN doesn't exist and non-attachable. Um, this policy ARN, uh, no such entity. Okay, so might we have done the mistake on the ECS. AWS controller load balance. Okay, so let's check the policy name is correct. The policy name is correct. The policy ARN is also correct, and load balancer policy. Okay, so once I click enter, uh, an error while occurring the attached policy. The policy controller does not exist, or it is non-attachable, not attachable. Okay, so let's create an IAM account for now. If we get any error, so we need to look out for the particular ARN, if this ARN exists or not, or what is the issue we are getting. So the ARN is particularly this one, and the it, we have created creating a load balancer which have a namespace inside. We can what where you can get the namespace inside the inside over here on the EKS tab, elastic Kubernetes service. Inside the cluster itself, you will get the namespace itself. So on the which namespace it will run. So on the particularly okay, I'll show it to you on the command line itself. Connect it to the EKS cluster. So what we can do now, we can just copy the EKS cluster command and just click on enter. So it create a load balancer for us. What it can showing, it has no OIDC provider. It doesn't have authentication broker. So first we need to create that authentication broker itself. So it has provided the command. It has a EKS utils associate IAM provider region, which is our region and cluster name. So this is our command, and once we click enter, it will create a OIDC provider, OIDC broker itself, and we need to approve it. Once it will done, we can get the yeah. It has created the OpenID connection provider, and now we can create a IAM service account. So okay, so what it can show it to you, uh, the service accounts that is already existed in Kubernetes, you can override this account. Okay, so there is no task left. So we not gonna override this account. Um, Amazon. Okay, so what we need to do now, we can connect to our cluster itself, and let's look. Is that it has created the load balancer now. So inside the load balancer, you will see our load balancer is present over here. Okay, we haven't provided our basically what we can say. We haven't attached uh, we haven't created any service, and we haven't created any service for our cluster itself. So we have created a node group, we have created the service account, but we haven't created any service to like ingress service to authenticate to expose this container outside. So there is no any service such as. So in the ingress, there is no ingress controller right now. So once we create an basically once we create it, we can get it from there. So what we can do now, um, we can run one command, which is this one. So run AWS update the kube config on the region. So I have a command over here on the uh, over over on my GitHub account. So am okay. So I need to get that from pipeline itself. No issue. Just copy I am copying this command from here. Just copied it and we can paste it over here because it has this machine is connected to the AWS, so you can directly do the query. So, okay, South one is the region. Once it will do it has saved the kube config file on my directory itself, which is the directory, and now it has showing the AWS command platform. We need to install the AWS CLI on this particular machine itself. So it has created the cluster. Now what we need to do, uh, we need to install the AWS itself. So this is our AWS CLI install, because we need to download that particular package from the AWS itself, and we can unzip it and just we can install. So Linux and ARM64, this one. So we can download this particular package. Again, it will require some time. Again, it's on your networks. Uh, unzip it. Okay, where it is. Yeah, unzip it. Okay, it has unzipped all the things. Now we need to go on AWS and we need to just just install this setup file. I guess it is written on bash itself. So where yeah, we just need to install this. So only over here, you can click on install and AWS CLI. Yeah, AWS CLI is installed now. Try to retype the failed jobs. So I'm running this particularly this pipeline itself. It will do all the activities such as pull the image or configure it. So it has no the kubectl command is not found. No issues. We can what you can do install kubectl. Kubectl. Also need to install the EKSCTL because we have used this command. Install kubectl. Install on Linux. We have this command. Just copy and paste. We have kubectl. Now what we need to do? We just copy pasting the command from here to downloading the kubectl, and we need to validate the binaries. Paste. Okay, and checksum is failed. Someone. Okay, we'll see. Checksum is failed. We need to provide the permission. It was providing specific permission, and it will move that file to the local bin. So no issues. Just paste it, and it will directly move. Just you need to copy paste those things, and you can just try kubectl -1 version. Just version, I guess version. Once you do that, you get uh, will get this. So let's try to get the version of client, and yeah, it is working correctly. So try with the YAML also. Uh, paste. Yeah, we are getting the response with the YAML also. No issue. Kubectl get nodes. Not able to connect right now. Might there are some issues. Okay, so let's rerun this and let's see if we get any error or not. So it will require some time again. Okay, it has deployed our service.yaml, and we'll check out this pipeline is successfully done. So now let's try to uh, look the commands, the kubectl get status. Oh, sorry, kubectl get pods. This is how pod is running, and kubectl get all. So this is our application load balancer has been created, which is working on port 80. So it has a replica set. It is deployed one application. It is a cluster IP, and let's try to connect with that resource itself. So it is working on port 80. Let's check the load balancer. It has connected with the machine or not. Okay, there are some issues with the health check of that particular target. So it has out of service right. So let's add another replica of our application. So what we need to do, you can go on replica set. Sorry, not on the replica, on the compute. Go on over here and we can click on edit. The minimum size we can keep at two. Desired state is a two also, and the maximum is three. Let's save changes. It is updating the. It is in progress. It will create another EC2 instance, and throughout that EC2 instance, it will host our application. So let's wait for some time. It will connect and register our EC2 instance automatically over here, and you will see the status available. So let's wait for some time and we'll check. Okay. So my one of our container is starting. It is in both of the container are in service, and we have successfully deployed our uh, Zomato application or on our cluster itself. It has accessing over the our DNS on the DNS on the uh, DNS on the load balancer. It has a node group which has it is node group. It has node group which is connected to the EC2 instances. It has a cluster role which is connected to the cluster EKS cluster itself. We have created the IAM service account, and it is connected uh, to our pods itself, and it has we have created the ingress controller. Inside that ingress controller, um, we have provided our there you go. You have a namespaces. Inside those namespaces, you can deploy your application. So our current namespace is cube system. Inside this cube system, we have deployed our application. So on the we have created the services. We have created the zomato.service. Inside that, we have a load balancer. Inside this load balancer, we have a three. Inside this load balancer, we have a like we can access the application from the load balancer. We have configured all those things as per our requirement itself. So that's it for today.